So what we want to do in this video is we want to continue exploring circular motion, and we want to discuss the forces acting in circular motion. So whenever we have some object like our ball here and it's moving, let's say it's attached by some string and you're a person, you're this person here holding this ball above your head and you're swinging it around. Well, whenever you're doing this, the idea is that the ball is moving. You can see here V1, and V1 is tangent to the circle at this point, but V2 has had its direction changed, but it's moving at the same speed. So we remember that the magnitude of V1 equals the magnitude of V2. It's constant speed, but the direction is changing, so we said that there had to be an acceleration, and that in order to have the acceleration we have to have some force. So when we look at the forces acting on our ball here at V1, we have one force. Let's say the ball is attached to the string. Well, then the tension in the string supplies us with the force. So when we sum the forces, let's say in this radial direction, this blue line direction, when we sum the forces in that direction, we sum the forces, we get one force. The result of that force is MAR. Now, when we sum our forces, we have the one force, and the result of that force is MAR. But we've said already that AR is V squared over R. So the idea is that this force, this radial force or centripetal force, is the result of summing your forces gives you MAR. And note, I put a warning in here that please note the centripetal force is not a force, it's the result of the summed forces. So you have any forces acting along that blue line, you would add them up to get the sum of the forces that would then be MAR. So when we're thinking about our object, the idea is in order for our object to be changing these directions V1 to V2 as we go around the circle, when we sum the forces, this force, in order for it to work and hold us in place, the result of the force, when we sum this blue circle here around the force, that needs to be pointing inward. Otherwise, the ball would do something else and it wouldn't stay in its circular path. So that's why when we sum our forces and it's pointing inward towards the center, that's when we say, the result of our radial forces is MAR. And so the result of our summed forces, we can replace AR with V squared over R. And so this radial force or centripetal force is an inward acting force. And note, though, as we mentioned before, that this inward acting force is always the result of something else. So in this case, when we're swinging the ball around above our head, the tension supplies this force here. Or if you could imagine that this was the sun here in the center, this is the sun, and then the red dot is the Earth going around the sun, well then what's holding the Earth in the orbit is the gravity between the sun and the Earth. The sun's gravity is supplying the radial force, and it's holding us in our orbit. So remember that this centripetal force is supplied by something else, and it acts inwards on this object to constantly change these velocity vectors to keep them in that circle. So we know that this force is a center-seeking force, and it's a real force supplied by something, because if we had our string here earlier, we had this string here that the ball was attached to, and it was causing some inward force. Now, if suddenly we were to take and cause that to disappear, we cut the string, what happens? Well, this ball had its velocity this way. It had some v in this direction. Well, as soon as you remove the force, Newton's first law tells us, hey, this thing wants to continue doing what it was doing. Well, if its v was tangent to the circle at that point, then it's going to continue moving in that straight line path, tangent to the circle, at some constant speed until something else acts upon the ball. So we know that this force, this tangential force, acts radially because as soon as we cut it, the ball moves in a straight line path. So this is how we can test that our ball is moving tangent to the circle, because if you're swinging something overhead and you cut the string or let the string go, it will move in this tangent direction to the circle at that point. So these are kind of some of the basics of uniform circular motion.